Okay, here we go with video 6b. This will be quick because it's essentially a year 11 question. It just fits in with the topic. So we have population growth in a town, we have information about two dates, and we have a differential equation given and described. So assuming population growth is proportional to population size, that's what that means, of course. And we're going to estimate the population in 2020 and the population growth rate in 2020. So the most important thing as far as this topic's concerned, if we have dp dt equals kp, then that's a recognised differential equation with a recognised solution. So this has solution p equals a e to the kt. And in fact, we can do one better than that. The mysterious a is in fact the initial population, which we would call p naught. So really the key point of this video 6b is that if we know this information, then we can transfer it to this information. We don't need to go through any calculus to claim that. Now, having said that, exam questions will frequently have a part 1 that requires you to go through the derivation, and that's fair enough, that's part of the course. But if it's also part of the course to know the link between the differential equation here and the solution. So the rest of this is year 11. I'll do it quite quickly. All right, so here in this question, P naught is 12,500. I'm just going to note that 1970 t equals 0, that's my decision. It's a sensible one. Our other information, P23, 18,200, so that's 1993, t equals 23. We're trying to find P50, it's the year 2020. And we're also trying to find dp dt when t equals 50. You've probably never seen that notation before, but it is a standard and it makes, it's easy enough. Getting on with it. So we have P23 equals 18,200. What we don't have is a growth rate, K. So subbing into this, we get 18,200 equals 12,500 e to the kt. Divide through. And sorry, I should have put a value for t in here. So 23. Okay, so 23k is the log of 1.456, and I could keep an exact value for k, but I think it's instructive to write down a value, but this is important. Store it in your calculator so that we can use the full accuracy of it later. We are after 2020. In 2020, so P50, this is just a valuation now, 12,500 e to the K50. Right, put all that in your calculator. Note we have that connection. And so that's 28288,417 ... The question gave its population values to 3 significant figures, so that's what I'm going to do here. 28,300 people, 3 significant figures. So we have found this. Let's beef that up. There we go. We've found that part. And now we're going to find this part. How do we find dp/dt? Do we take this and differentiate it? No, we don't. We use this. Right? This is all the way back to where the question started. So in 2020, dp/dt equals kp. We worked out p already, it's to the left there, equals k times 28,300. I don't feel bad about using an inaccurate value here. I feel perfectly good about that. And of course, remember that the k is stored in our calculator. And this is, well, approximately equal to 462 people per year growth rate. There we go. End of video 6b.